This is CPM Calculus Chapter 5, number 30. Mr. Lyon was trying to find the points of inflection for the function f of x equals 3x to the power of 2/3. Since no value of x existed such that f double prime of x is equal to 0, that's the second derivative, he assumed there was no change in concavity. Andrew said that a point of inflection exists where the second derivative changes sign. Who is correct and why? Use the second derivative and the graph of f of x to verify your answer. Okay, so let's go ahead and find the first and second derivative. So f of x is equal to 3x to the power of 2/3. F prime of x, the first derivative, we can use the power rule. So we're going to multiply by 2/3 times 3x to the power of 2/3 minus 1. Remember, 3 is over 1, so we can simplify this. The 3 is going to cancel. This is just 2, because 2 over 1 is just 2, times x. And our new exponent, 2/3 minus 1, is negative 1/3, right? So f prime of x is equal to 2x to the power of negative 1/3. F double prime of x is just the derivative of the first derivative. Is going to be, we're going to drop this power now using the power rule. It's going to be negative 1/3 times 2 times x to the power of negative 1/3 minus 1. Now multiplying negative 1/3 times 2, of course this is over 1, so this is negative 2/3. X to the power of negative 1/3 minus 1, we're going to add the numbers and it's going to be negative, so that's negative 4/3. Okay, so something interesting we can note is, well, let's go ahead and just rewrite this. That's going to have a positive exponent by putting it into the denominator, which is currently 1. So it's going to be equal to 2 over x to the positive 1/3. And we could leave it like this, or we could even write this as 2 over the cube root of x, right? These are all the same. Likewise, we could look at f double prime of x, and we can write this as negative 2 over 3, right? And it has x to the negative 4/3 up here. We can move it into the denominator by making it positive, right? And then similarly, we can write this in a couple ways. So let's just write them all. This is negative 2 over 3, and this can either be the cube root of x to the 4th, or we can even write this as negative 2 over 3, the cube root of x to the 4th. These are all the same. Okay, these are all the same, and just want to show different representations. So anyway, we went ahead and it says in the problem we have Mr. Lyon, and he's saying there's no concavity, there's no change in concavity, and Andrew said that a point of inflection exists where the second derivative changes sign. Okay, who is correct and why? Well, the second derivative, where does it change signs? Okay, we could look at it in any of these. And first of all, is the second derivative ever 0? No, because we have in the denominator x, and the denominator can never equal 0. Similarly, f prime of x can never equal to 0, right? Because we have x in the denominator. X to the negative 1/3 means it's in the denominator as a positive x. So this is never equal to 0 as well. Okay, so who is correct? Well, Andrew says that a point of inflection exists where the second derivative changes sign. That's true. Andrew is correct in saying this. Right? So let's underline what he said that is correct. Alright? And Mr. Lyon says the points of inflection, there's no value where f double prime of x is equal to 0. Well, that means that it's never changing signs. So let's go ahead and look at the graph, because it says use the second derivative and the graph to verify your answer. So let's also look at the graph. I'm going to go ahead and graph 3 times x to the power of 2/3. Right, and then let's go ahead and graph this. Right, so look at this graph. It's like this and like this. Right, here's just a quick sketch of f of x. So what do you notice? The graph here is concave down on the left and also concave down on the right. And that shows us, well, there's no change in sign, because f double prime of x is never going to equal to 0. So Andrew's correct, but the second derivative never changes sign, right? So Andrew's correct, but not because, but f double prime of x never changes its sign, right? If f double prime of x shows the concavity, and this is concave down, right? This is concave down, concave down. Well, this side is also concave down, right? These are both concave down, so there is no point of inflection. Andrew's correct in what he says, but it never changes its sign anyway. Right, so this ends first CPM Calculus Chapter 5, number 30.